So we've done an awful lot with series in a very short period of time, and what I want to try and do is just help you organize your thoughts and talk about how, if I was looking at a series, how I would approach determining if it converges or diverges, and just kind of the order that I would work through. So the very first thing, if you have some series, the two things that I'm going to immediately look at are the divergence test or the alternating series test, because those are the absolute easiest ones to do. So if I'm looking at it and it's not an alternating series, if it's an alternating series, I'm going immediately there. If it's not an alternating series, I'm going to start with the divergence test, which, if you recall, simply says the series A sub n diverges if the limit as n approaches infinity of A sub n does not equal 0. So you just do the limit of the series terms, and it has to be 0 in order for there to be any chance that it converges. Because if you think, at some point you need to be adding 0, otherwise this thing's going to continue to grow. So we start there, and if you get 0 for your divergence test, then you have to keep going. Now let's say it's an alternating series. An alternating series is going to be in the form -1 to the n minus 1 times some a sub n. Okay, or it could be -1 to the n. To determine if this series converges or diverges, all we have to do is look at the limit as n approaches a sub n, and if it equals 0, it converges. So very simple. Also, for alternating series, something I might want to ask you about, and you might want to note, the series of the absolute value, so essentially doing the series without the alternating part, converges for what we call absolute convergence. So if I ask you about absolute convergence, I'm just saying take out the alternating part and see if it converges or not. So those are the two easiest ones. That's always where you want to start. So let's say you start there and you can't make any definitive statements. You can't determine if it diverges or converges yet. The next place you want to move are these three. You want to look at, is it geometric? Is it a p-series? Is it something that we can easily make a comparison to something that we know converges or diverges? So let's look at how we would use those three. So let's say you're looking at some series and you determine that it's geometric. Right? If it's geometric, it's very simple. For a geometric series, if the common ratio r was less than 1, it converged. If r was greater than 1, it diverged. So very simple, a common ratio, look at the ratio of the terms. If it's less than 1, it's going to converge. If it's greater than 1, it's going to diverge. Also might be a good idea to note, remember this series is going to be in the form a times x to the n minus 1, where a is the first term and x is the common ratio, that we can compute the sum by doing the first term over 1 minus x. So that's just an important note to add. If you determine it's a geometric series and it converges, I could even ask you to tell me exactly what the sum is. A p-series. A p-series is going to be of a series in the form 1 over n to the p. This is a super easy one to determine if it converges or diverges, because simply If P is greater than 1, it converges. If P is less than or equal to 1, it diverges. P-series are often a great thing to use for all these other tests additionally that we had. You can quickly do a comparison test with them, and they're also useful for the other ones. Using that limit comparison test is a good place for the P-series also. The comparison test, if we know two series are positive, and one of them is always less than or equal to the other one, then if the larger series converges, then we know the smaller series must also converge. And the opposite is true. If the smaller series diverges, then the larger series diverges also. So if we can make a quick comparison to something we know, like 90% of the time I'd say with these it's going to be a P-series comparison, then we can make a determination about it. Alright, so let's say you can't do any of those three things. None of those apply. It's not geometric, it's not a P-series, and you can't use this comparison to prove anything definitively. The next thing you probably want to ask yourself, because we've done this quite a bit in Calc 2, is can you integrate this thing? The reason I'm saying that to integrate it is if you take your series and you turn it into some function, if the definite integral of that function converges, I should really put dx there. If the definite integral converges, so does the series. And if the definite integral diverges, so does the series. So that gives you a mathematical certain way to do it. Now, a couple things you might want to keep in mind with this integral test is you want to make sure that a sub n, for this test, a sub n is positive and decreasing. Most of the time that'll be the case, or otherwise the thing would have to diverge anyway, but for our case, we want to make sure that a sub n is positive and decreasing before we move on with this test. Alright, the next way, if we can't do some sort of integration, if you have something that's very difficult to integrate, the next place that I would say you want to go is the ratio test, because it provides you a mathematical way also. So for the ratio test, what we're going to do is we're going to take our series a sub n, and we're going to look at the limit as n approaches infinity of a sub n plus 1 over a sub n, considering their absolute values. And we're going to see what that thing equals. Hopefully it gives us some number L. If we do this computation and we get L, if L is less than 1, it converges. If L is greater than 1, it diverges. If L equals 1, move on. We've proven nothing. So if you've gone through all this process and you've done the integral test, and you can't do that because you can't integrate, and you do the ratio test, and you get 1, then we've got one last place to go. And that is to use the limit comparison test. Now, this is probably the most difficult one because you need to choose the comparison that you want to do, or you need to find something that you can, some series that you know converges or diverges, and you need to pick the math. So to do the limit comparison test, you pick a b sub n, a series b sub n that you know about. Meaning you know if it converges or diverges. And then you're going to compute the limit as n approaches infinity of a sub n over b sub n, and hopefully you're going to get some number c. If c is greater than 0, then both series converge or diverge. And again, you picked some b sub n that you knew about. More than likely it would be a p series of some sort. 1 over n is always a good one to consider here. But you picked some b sub n that you knew about. You did this calculation. If you get a number greater than 0, then both series must converge or diverge.